Hey everyone, today we're gonna be doing a lead code question which is add a row in some tree. So we are given a root of a tree. We are given also a value in the depth. So we have set to be like add some value between a particular row, or you can say a particular depth or height. So suppose this is a tree, this is a binary tree. What we need to do, we need to add some row in between. So if the height of the if the depth of this tree is given 1, we need to insert in the top. Similarly, like we are given something depth is given, we need to insert in the depth -1 area. Okay, so we are given some value, some current, you can say root of a tree. There are some examples. They are given the constant like number of node in the tree can go from 1 to 10 to power 4, and the depth of the tree can go from same 1 to 10 to the power 4. The value inside node can be -100 to 100, and the value of that node, you can say not value, the insert value, like what we need to insert in between, that can go from like -10 to the power 5 to 10 to the power 5. And the depth also can go like they can insert at like very start, or they can go from at last, like from root they can go to leaf, so they can be inserted in any position in the front as well as the height of the tree, like last node. So we'll see like how to do this with some example. So let me make that tree my here 1 second. So we are given some tree. Our tree is like the first tree was given 4, then 2, then given 8, 3, 1, and 5. So suppose this is a tree. What they are saying, like this is given some root, like we can say this might be a root. I'll say okay, this is our root. Okay. Also we are given two things. What we are given? We have some value to be inserted. Suppose in this case it is 1, and we are given the depth. So we are saying like, okay, you need to insert some value at depth 2. So depth 2 means one more thing, like they said, the node depth will be starting from 1 instead of 0. So if they say you need to insert in something in the first depth, it means you need to start in the root. If they are saying it should be inserted in a depth 2, that means you need to insert before this row. So what you can think of, like we are just inserting in some between of the row. Like if it is saying insert here, you need to insert something over this. Also, if like given depth is 2, depth 2 means you need to insert before this row. So if you see, we have something like if I say for binary tree, it means it has some left and right. What it means, like we can do two things. Either either we can go row by row, or you can say level by level. We can do a level order traversal. If you see here, we can do level order traversal. Like this is our level 1. I'll say okay, this is my level 1. This is my level 2. This is my level 3. So what I can say, okay, I can do a level order traversal, and what I can say, okay, depth 2 means insert before level 2. So I can store this level, this level, this level, and I'll say okay, depth to here. Insert one more array. You can say if I do level order traversal means I have 3 different arrays. Like this is the one array, this is one array, this is one array. Because I'm doing level order traversal, I have this as a complete row. What I can do, I can add one more row in between, and I can again create a tree from it. But I have a better and optimized way. What we can do, I can say, okay, let me know if you reach to the current depth. Either we can start a current position, like current depth is this, and when it matches with this, like see, if I start from here, this row, I'll say, okay, current depth is 1. Again, current depth is 2. Current depth is 3. For this particular row, the depth is 3, 2, and 1. I'll say, okay, when this depth met with this condition, like if this reaches to this particular condition, just insert before this. So if you wanted to insert something before this, you mean I just need to have a previous pointer. So instead of going to the next pointer, what if like we can count of a depth -1? Like I'll not compare this current index, or you can say current depth with this depth. I'll say okay, current depth. You can say this current depth equals to this, you can say our given depth minus 1 means I am just one depth before this. So I can insert between this. So what I can say, in the question they are saying, okay, you need to insert some element in between, which is if you insert this particular row, this element should be inserted in between. If I say, okay, I need to insert in this between, I'll say, okay, remove this one, remove this one. You need to insert two element, which is value 1 both the side. Okay. Again, what I need to do, I need to connect this left to the left, this right to the right. So if I insert some of the element to left and right, it means I need to connect that to the complete left, like it will have left child this, it will have right child as 1, and it will having this left child as a subtree of a 4. So it means like I need to insert something which is like doing a chain. This left child will go to this left child, its left right child will go to its right child. Okay, and we'll insert one element to its right, one element to its left. Similarly, if they say I need to insert in front, if you say I just need to insert in a first depth, it means in the question they are saying if something is wanted to insert in a first row, just create one node. I'll say okay, one is created here and it will contain the left pointer as the root of the tree. It will say okay, 4 here. I'll say if I just need to insert something in start, I'll say start, just have the complete tree. I'll say okay, I'll have a copy of this tree completely. I'll say okay, make this copy and insert to the left of this whatever we have created. So let me create 1 second. I have this tree. Okay, let me make a copy. Sorry. So I have this as a tree. What they are saying like okay, if you are given a you need to insert in the top, or you can say start. Just make a new node and point its left as a complete subtree. And you can if they are saying something to insert at last, you can simply like add two nodes of one element for all the nodes. So if they are saying something to be inserted, it means all this particular level should be inserted with the same value. So let me write some code for it. It's like very easy and basic question. And let me create like initially I'll do a, you can say, depth first search. Let me create a function called DFS. Like I'll do recursive solution for this. I will be having some root. Okay, I have some value to be inserted, and I have my current depth. Okay, I have my depth, you can say. So what I'll say, instead of calculating my depth equals to current depth, I can decrement my depth. So what I will be doing, like I will be checking if our given depth, okay, our given depth is equals to 1 means I just need to insert something in my start node. So what I can say, just create a new node. I'll say okay, tree node with having a value, you can say value will be our value, and it will be having a left child equals to what, our complete subtree as a root. Okay, I will return a you can say left subtree with a new node. Okay, if it is not a case, I will be calling my DFS function. Okay, I'll say okay, DFS pass our root. Okay, this is tree node. We have some value which is given in the function, and we need to insert a depth minus 1 because we are like we will be like inserting before some row. So we will be passing some like depth, and at last we will be returning our root. So if you say in this particular code, I have this root, you can say node as passed by reference. So whatever change I will make in it, it will be pointing something in between. So if I say I have this particular row, I have this as a, let me create something. If I have this node, I have two values. Okay. What I'll say, if I do something in this between, if I see this is my left pointer, this is my right pointer for this node. If I do some changes, if I say okay, make one copy of it, just include something in between, I'll say okay, just include 3 in between with this left. It means I am just changing my pointer address. Okay, so what I need to do, I'm just doing like doing the changes for this particular position. Let me write my recursive code now. I'll say, okay, if depth reaches to what? Equals to 1 means I'm just one more thing. Instead of like doing the current code, or you can say current index, what I'll say, I'll pass my current depth, and I'll say, okay, initially I will be passing as depth minus 1 means here it is asked for 2. I'll say, okay, insert here. It will be passing as a 4, 1, like 4 is a root, 1 is a value, and depth minus 1 means 1. You mean I just need to insert at first position, like my current depth is this. Let me create 2, 3 more example, like I have 1, 2, I'll remove this one first. Okay. So I have 1, 2, 3, I have 4, I have 5, I have 6, I have 7. Okay. If somebody says you need to insert in something like in third position. Okay. Or let me say depth equals to, I need to insert in depth equals to 4. That means I need to insert, this is depth 1, depth 2, depth 3, and depth 4. I need to insert something before this. Okay. Something before this means here what I'll say, okay, I will be passing my, instead of like pointing the current depth, I'll pass my depth minus 1 value. Means I have this as a depth minus 1 will be passed here, like current depth I'll checking is 3, depth given for me, so I'll check, okay, 3, for this case I'll say 2, for this I'll say, okay, 1. It means I reach to my current depth, like for the next case I just need to insert some value because I'm just counting 1 before. Instead of pointing to this, I will be pointing to this because I need this as a reference. If I came here, I don't have reference for this parent, but for parent I have child's reference, so I will be counting my current depth 1 less than the original depth because I need to insert before this. So okay, so let me create, if depth is equals to 1, like same thing, if I reaches to some root, I need to insert something. I'll say, okay, you need to what? You need to have its root. I will be creating my new root. You can say left pointer. I will be creating a new node, which will be like tree node. Okay, I will create a new node for the right and left child both. I'll say okay, right. Now I'll say both. I will be passing my. You can say value will be passed as same. Value will be 1. Not 1, value is like passed in a function. I'll say okay, value will be value for both. Okay, value will be both. Now left, a left child of a tree will have the subtree of a right child. I'll say okay, right pointer. See, this function is asking 2 parameters, value, left child, right child. If I say I'm creating a left child, it means I don't need to create a right child. For a particular case, like a subtree from left will be continuing to go to left. I'll say left child will be having a copy of a complete left node. Okay, I'll say okay, make a copy of a this particular code will be copied over here. If you're getting confused, I'll say okay, I have some left and right copy. I'll say I'll create 2 subtrees. I'll make a 2 clone of it. I'll have its like indexes like left tree will be a subtree of a current root left tree, and for right I'll say okay, copy a right subtree. It will create 2 different nodes, and I'll say okay, point this to a current root, current dot left, you can say current node right will be like left, and same for right. I'll say okay, for right and left both you need a copy. So I'll say okay, make your right child as a right subtree or right clone we have created. So we have created this. Okay. Now if it is a case, well and fine, you just return can from here. Okay, I can return from here. You can also say, what if our root is empty? I'll say, okay, just mark root equals to none. Okay, equals to none means I don't have any node for this case. I can simply return from here, return something, just return nothing. Now for each subtree, I need to do a recursive call for its left and right child. If this two is not case, I need to go to left and right child for each tree. I'll say, okay, go to your left child and same value, but depth will be one less. I will be checking for one less depth. Okay, for both the case, I'll go for right call and left call. At last, I'll just compile this code because we are doing the changes in place. So let me compile this code and it got accepted. Let me submit this code as well. So if you see, we have done this code in a linear time, like number of roots, or you can say number of nodes in the tree, and something like a height of the tree, maximum height of the tree will be of a space complexity for the recursive step. So that's all for today. Thanks for watching.